Hi, everybody. Let's see. Let's get that share going. Doing okay on the test. Not bad. We're doing good. We're living. We're living life. Love it. Great job, everybody. Wonderful. Good. Let's see. That's good. I'm in screen. Okay. Awesome. All right. Let's get started on my favorite thing. Entire screen. Did everybody feel like the test was not bad? They believe me now? Cool. All right, we're going to start out with a quick disclaimer. Yep, it was good. Awesome. It was okay. Yes. Awesome. Great. Great job, everybody. So proud of you. Was there a repeated question a lot of people got wrong? Don't know. I haven't gotten that far yet. I'll look at it and see. I didn't write the test, so it was questions that Dr. K has been using for 10 years, so I'm sure she's figured out what questions are good and bad at this point. So yeah, but everybody did pretty good. One thing I did notice, because I like trends and numbers and stuff, I hate math, but I like looking at trends. One thing that I did notice is everybody who did the test, almost everybody who did the test before Saturday or Sunday, like before the weekend, straight A's, mostly A's, like 1B. People who did it like ahead of time, who were like not waiting till the last minute, mostly A's. People who waited till the last minute, worst grades. Okay, so I'm not telling you how to live your life. I'm just telling you there might be a trend there. Maybe if you prepare a little better, maybe if you study a little more, maybe if you are a little more on top of it. Okay, so I'm here. I'm here for you. If you need more from me, you let me know. Okay? Deal? Awesome. Thank you. You're welcome. I live to serve. Okay. Quick disclaimer. The views expressed this week are not that of the Lanier Technical College. They are my own opinions, based in fact. They are they're my own opinions, okay? The state of Georgia tells you that I have to teach you this. Whether or not I believe in it is not up to the state of Georgia. It has to be taught. That's not my fault. Vote accordingly come November, okay? So, let's talk about the lymphatic system, if you believe in that kind of thing. Let's get into it. This is AIDS. I don't know why this is here. Probably because it's got something to do with immunity. All right, functional anatomy of the lymphatic system. I assume that most of you have read my announcement by now, which will be going away because I don't want that knowledge to be stuck around forever. I want you to read my manifesto and move on with your life and form your own opinions, okay? I just happen to have the correct opinion, but the functions of the lymphatic system, they drain excess fluids away from tissues and back into circulation. It's a drain, it's a sewer, okay? They say it houses the cells necessary to clean fluid before draining into circulation. Interesting. Transport fats from the digestive tract. We will get into that during the anatomy section, okay? And I just realized that I did start this by saying this is functional anatomy of the lymphatic system. So We're going to get into that like right now. Other functions, signaling device to give feedback to the United States government about your health and big pharma. The state of Georgia's opinion, which makes sense because they wrote the curriculum. So, all right, the anatomy of the lymphatic system. Man, that's bad. Sis, really cut off? Okay. It's mostly vessels, and this is the crux of why I don't believe in the lymphatic system. A little bit about me. I've done maybe 1,000 cadaver human dissections at this point. Don't see it. I don't see it. It's not there. You know what is there? Blood vessels, arteries, veins, all that stuff. Lymph nodes exist, but they're not connected to anything. I'll be honest. It doesn't look like anything. I don't believe it's there. Couple key features, definitely there. I think, personally, that there's an ulterior motive with the lymphatic system. Draw your own conclusions. But they say it's mostly vessels. Transport lymph from the tissue to the bloodstream. What is lymph? Lymph is fluid. Go figure. Cells. There are immune cells, including phagocytic cells, and more importantly, lymphocytes. Go figure. Lymphocytes. Tissues. There's a specialized form of connective tissue. Other organs don't have specialized forms of connective tissues, but isn't that convenient? Organs, specialized organs that house the cells of the lymphatic system. So, the lymphatic system has vessels, cells, tissues, and organs, much like everything else in your body. Okay? So, the vessels cover the arms and legs, and they convey lymph to the larger lymphatic vessels in the torso. So, it is a sewer from your extremities all the way back. Okay? Back where? Back to your heart. We'll get there. All right. So, one thing I want to point out, capillaries right here. So if this is a tissue cell, if this is a cell where blood delivers oxygen and all the other exchange of nutrients comes from, this is a lymphatic vessel. They are interwoven within the capillary system, okay? Pretty convenient that they just laid this on top of a picture that you would see in an anatomy book. A little more creativity there, government. So they're kind of woven within, and they basically work off of osmotic pressure. Okay, so it's an overflow sewage system. Okay, so think like retention ponds. That's what's going on in the lymphatic vessels. Okay, so you have things going on here, and then you create pressure differentials between all the fluids and the cells and stuff, and all of that just gets pushed into the lymphatic vessels. Okay. And then from there, the lymphatic vessels, let's say we start here, move up through here, through the vessels, into some lymph nodes, passing through some other lymph nodes. They drain into this area called the thoracic duct, which is definitely not an antenna. And then from there, it drains into the superior vena cava, and it goes into the heart, okay? And so all of that stuff goes into circulation. So I know what you're thinking. Don't veins do that? Kinda. All right, so here is the capillary exchange. So if this is the capillary, so this is, as we remember, we have arteries, we have arterioles, and we have capillaries. So if arteries are a couple cells thick, arterioles are a little bit thinner, capillaries are single cell walled lumens. Okay, so it is if this is a cell, this is a whole 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 cell. Okay, so they're stacked on top of each other and next to each other. Okay, so what that does is it allows single blood cells to pass through, and all of this exchange goes through by filtration. Okay, and other methods. So if the arterial end has a net positive pressure, if it's got a higher pressure here, why? Because it's being squeezed by the ventricle, the left ventricle, okay? Blood's being shot and squeezed all the way down. You're moving your thumb over the top of that hose, okay? It goes into here. It's about 10 millimeters of mercury positive, okay? That'll push blood into the cells that are adjoining, right? And that causes fluid to be pushed through, right? So osmotic pressure, right? Or hydrostatic pressure, not osmotic. Okay, and then eventually that pressure will fall to nothing. Okay, and then on the venous end, you'll have a negative pressure. So it'll start, you'll have a positive pressure here, and then you have net negative or net zero right here. And then right here, the cell has become so swollen because it's got all of the fluid that it's pushing it back. So the positive pressure is here. So the positive pressure is here, it's here, it's here. Okay. That will cause reabsorption into the venous end of the net filtration pressure. Okay. So fluid re-enters the capillaries. All right. And it's less than blood colloidal osmotic pressure. Okay. Colloids is blood. Okay. So it's like colloids are things floating in blood, right? So it's blood with things in it. All right. So the pressure right here is 25 millimeters of mercury. So right here. And then up here, it's 35, right? So it's 35 here, 25 here, 30, 30, or 25, 25, and then 25 here, 35 up here, okay? So pressure gradients, that's all the body is pressure gradients, okay? So there's no net movement of fluid near the midpoint, so things are happening all at a net zero, and then reabsorption happens on this end, okay? So it's the venous side. But Matt, I thought we were talking about lymph. All right, so lymphatic capillaries, those go between the capillaries. So you see where this is the net zero right here? This is net positive, this is net negative. So you have arterial, and then capillary, and then a net zero capillary bed, and then a net negative, and a venial right here. So venial is basically an arterial, but a venous segment, okay? So from a cellular level, here's what you got. You have interstitial fluid. So there's fluid between all these cells. They're not just butted up to each other and there's like nothing between it, right? Some a little bit, yes, but like they curve and they create little like circles, right? So they don't sit perfectly on top of each other. There's a little bit of space. So there's fluid between that, okay? So, and that's all held together by like collagen fibers, so connective tissue, okay? So you have these things called endothelial flaps. So they're just flattened lymphatic endothelial cells that blood can or interstitial fluid can just drain into. So area of high pressure goes to an area of low pressure. Now this becomes the area of high pressure, and this is the area of low pressure. So you're just squeezing it out of the balloon, basically. It's a reverse udder, pretty much. All right, so interstitial fluid slips through the spaces of the overlapping endothelial cells that compose the lymphatic capillary. Okay, so if this whole thing is a lymphatic capillary, it's just kind of laced in between all of the different capillaries. So as blood becomes too positive here, it leaks into the lymph, right? As it becomes too negative here, the interstitial fluid leaks into the lymph, okay? And then all of that just kind of drains. How does it drain? Pressure gradients and gravity. Okay, so pressure gradients that'll create an area of high pressure, say in like your toes of your feet, obviously, because you don't have toes of your hand, and then that will squeeze the blood up through the lymphatic system into the duct. Okay, but the other thing is like you don't have a heartbeat at this point, right? Like there's no heartbeat in veins, so it's just pushing blood up as the pressure is building on the other side of the system. Okay, so that's the lymphatic capillary. Okay, any questions on the microanatomy of this? Oh, one last thing. There's valves in here. So you see these little valves, just like the heart valves prevent backflow, so do the valves here. Veins have valves, right? Because gravity will pull the fluid back down. So they need valves to catch it. And then when you squeeze a little bit, you're going to close the valve. Got it? It's the same thing in the lymph. It's almost like somebody created a system that already existed and then made it green. Okay, So, oh geez, oh gosh, oh gosh, oh gosh, please stop, please stop, please stop. Dang it. All right. So lymphatic ducts. So all of this leaks into one big central area. Okay. So this is the cisterna chili of the thoracic duct. So it's a big space in here, right in the middle of the mesentery and all of the bowel right there, or it would be if it existed. And then you have what's called the thoracic duct. So that goes from the cisterna chili all the way up through the thorax. It looks like an antenna sticking up from the cisterna chili. And then that drains into the subclavian veins. Okay, so that goes in the veins and then it goes into the heart. Okay, so all of this is separated. Dang. Okay, so the right side goes straight into the subclavian vein, right? All of this dumps into here. The left side of the body, all of this and the lower extremities dumps into the cisterna chili and into the thoracic duct, okay? Which goes into the left subclavian vein, okay? So all of that drains into there. So if you're gonna have fluid buildup, where might it build up? If most of the pressure is down here and over here. Throw it in the chat, fam. Limbs. Which limbs? Yeah, limbs, but which ones? There's 4 of them. 3 of them are the right answer. Legs. Yeah, legs and then left arm. Right. Why legs? Why legs first? Gravity. Gravity because legs first. Okay. Yep. Gravity. All right. So gravity. It's gonna build up here. It's like filling up like a Tupperware full of soup or something. So it all goes to the bottom first, and then it kind of overflows into the arm. So if you see something like this, lymphedema, right? Fluid buildup. That is a direct disrupted flow of lymphatic fluid into the legs. It's not draining, it's getting caught up in the lymph nodes, right? So it's just staying on this left side, right? Right here in the legs, okay? If you have somebody who's got a right arm swollen, is that like a really big systemic problem? I'll give you the answer. No, it's not, because it's just the right side of your body, okay? It's not the left side of your body. If it was the left side of your body, you're going to dig a little deeper, okay? Right side, it's just right arm, right subclavian. That's it. Figure out where the problem is between there, okay? So this is what it looks like when that builds up. So when you get lymphedema, lymphatic edema, edema is fluid buildup. So this is different than just like swelling. This is like fluid buildup. And you can have what's called pitting edema, where if you stick your finger in it, it creates a pit and then it just stays there. Okay. All right. It's kind of like Play-Doh. When you stick your finger in Play-Doh and it just leaves an impression, that's what's going on. All right. Organization of immune function. So there are barrier defenses, there are innate immune responses, and there are adaptive immune responses. There's 3 different things going on, okay, with immune function. All right. And by the way, that's all the anatomy for the lymphatic system. That's all they want you to know. Just a small little piece. Just what's that antenna going on in there? Oh, it's a thoracic duct. Yeah, okay, sure. Yeah, don't ask questions. You'll never see it in a cadaver, but sure, why not? All right, so what are we talking about? Organization of immune function. So let's talk about the hematopoietic system of the bone marrow. So all of this is stemming from lymphoid stem cells, okay? So remember this from last time? This giant thing that everybody hated? Yes, it's still important, okay? So all of the cells of the immune system arise from differentiation of hematopoietic stem cells, okay? So platelets are fragments of megakaryocytes, okay? These are products that fight infections, right? And these are immune cells, okay? lymphoid stem cells, lymphoblasts, immune cells, okay? Not immune cells, but important. Immune cells. So this is immunity. This is fighting stuff, okay? Spies, soldiers, Tinker, Taylor, okay? Don't worry about Tinker Taylor. Okay, so types of lymphocytes. Percentages of white blood cells. So lymphocytes are white blood cells, right? So there are B lymphocytes, and 10 to 15% of your lymphocytes are B. And what those do is they generate diverse antibodies. They float around, and anytime they see something that they don't recognize, they go, bink. All right, now I'm going to recognize it for the rest of your life, okay? And then they proliferate, right? So this one cell picked up 5 antibodies in its lifetime, and then it doubled, right? Because cells divide, right? So now we have 2 daughter cells, and they run around and they pick up different things, and they pick up 5 more, right? So you've got, now you're immune to 15 different things from one cell, okay? And there's like 40 billion cells in your body, okay? So eventually they all catch everything, all right? That's why when you're born, you get sick all the time. When you send your kids to daycare, they get sick all the time because they've never run into those things. So their body's creating immune responses, building up that immunity, and basically expanding their encyclopedia of things that I found that make me sick. Okay, so B lymphocytes, it's their fault. T lymphocytes, those secrete chemical messengers, so cytotoxic T cells, helper T cells, and suppressor T cells. These are doing battle, okay? These are fighting. These are spies. These are fighting, okay? These are just picking up antibodies and tagging stuff and pointing out where to go for all the other cells. These are doing the fight, okay? They're linking to viruses and bad things, and they're going, kill it, okay? Helper T cells, same thing. Like they're there to help out, obviously. Suppressor T cells, they suppress immune response. So like they go, okay, guys, chill out a little bit. We got it. Go. Okay. All right. So plasma cells, which are included as B cells, those secrete antibodies. So you have they're picking up antibodies and then they secrete antibodies. Okay. So they're gonna go, okay, I see that. Bing, I'm going to pick up a little antibody and then I'm going to drop it into the bloodstream. The B lymphocyte will pick up that antibody and go, oh, hey, yeah, let me add that to my dictionary, okay? And then there's natural killer cells, 5 to 10%. Those do exactly what they're telling you. They like nothing tricky about those. Natural killer, they're killing stuff, okay? Murderers. All right, lymphoid organs and lymphocyte development. So where do these grow? Bone marrow. I don't know what bone that is. I've never seen a bone that looks like a circle. So, but that's what it looks like. Maybe that's like an ice cream scoop of bone. That's probably what that is. Okay, so bone marrow. They grow in the bone marrow. Okay. They grow in the thymus. Okay. So one thing about thymuses, thymuses. One thing about the thymus, when you're a baby, you have a big old thymus, okay? If you look in like a baby chest, like if you just like look in there, you take a peek, you've got a huge thymus and it covers like the whole heart. And it's obviously a thymus, okay? It's got a lot going on, all right? If you look into like an old person, so not a baby, an old person, they've got like this little shriveled thymus and it's all fatty and there's all fat all a bunch around it and there's like not a whole like it's infiltrated with fat and it's not really doing anything, okay? The reason is because the thymus is generating cells that are creating immunity, right? So once you get to a certain point, you don't need to like keep generating new immunity responses, right? You pretty much have gotten everything after a couple of years, after like probably 20, 30 years. So after that, it starts kind of tapering off. So thymus, it doesn't develop, it doesn't continue developing. It starts kind of like being like, my job here is done. You guys enjoy life and all of its wonders. And then it just kind of fades into oblivion, right? So thymus, that's what that is, okay? So a cross section of the thymus, it's got a medulla, right? A middle section. It's got a cortex, this darker section, and then trabecula, which is these little compression things. Okay. And then there's a fibrous capsule around it. Okay. So this is what it looks like if you like cartoons, and it looks like this. Okay. So this is blood vessels. These blank spaces, these are blood vessels. Okay. And you have dendritic cells. Why do you have dendrites in the thymus? Could it be because there's a nervous response associated with endocrine system, right? Probably. So yeah, so that's going on there. And then you also have macrophages that are kind of growing around there. All right. What's down here? Clearly visible in the light micrograph of the thymus of the newborn. Yeah, so this is the thymus of a newborn, and in an adult, it doesn't look like this. It looks terrible. So that's what that looks like. Okay. Secondary lymphoid organs. So things that are secondary. I don't know. Is that primary? Yeah. So these generate lymphoid cells, right? Bone marrows. These mature lymphoid cells. Let's think of it that way. Why not? All right. So all of those cells, they grow up and they get out of the house, and then they start circulating, and they come in here and they go, oh, spleen, I'm going to hang out here. And they'll mature in there, and they'll develop, and they'll meet other friends who have run into other stuff, and they'll pick up new tricks, and then they'll go out into the world to fight the good fight. Okay. Lymph nodules, so lymph nodes, right? That's what these look like. This isn't a weird orange. And they do the same thing. So they masses, they kind of hang out and wait there. That's kind of what they're like. They're like a trap, let's say, and they're definitely not submitting information to the government. They're just waiting there, right? And then let's see, what is it? Lymph node, spleen, lymph node. So lymph node, that's this, and then spleen, and then the lymph nodules are more like the areas and stuff. Okay. So, oh, good question. Hang on. Nobody asked a question, but I thought of one. Okay. So one thing you'll notice right here, all right, right in the mammillary tissue. This is a biological woman, obviously. Don't assume. But so there's a lot of lymphatic duct tissue in here, okay? Why is it important that we have lymphatic tissue in a place that is exposed to a newborn? Question and answer. Somebody throw it in the chat. Take a guess. While you're guessing, I'll give you my thought, which is because the lymphatic system is not developed enough in newborns, so it's transmitting through the mother. That's just any guesses? No guesses. Nobody wants to guess. You guys spent the whole week picking the right answer, and I just want you to guess a wrong answer. Can you repeat the question? Yeah, why is there a whole bunch of lymphatic tissue around here, right in the mammillary area? Breast milk for antibodies? Yeah. Yeah. So you're creating breast milk right here because there's glandular tissue that you're secreting into the newborn, right? So you're going to give some of those antibodies into the newborn, right? So they don't have that immunity, and part of building up that immunity is getting it somehow. So you don't. It's not like a blood transfusion. You're not just going antibodies straight into the bloodstream because obviously it's being digested. So not all of it's getting through. It's not a perfect system, but it's short of hooking up a direct transfusion into a newborn. It's a pretty good system. Okay, so some of that antibodies are going to kind of like go into the stomach and then like seep through the stomach lining and out into the newborn body, right? So that's what is important about this. Now it's downfall too. Learn lots from breastfeeding with COVID. Yeah. So yeah, they same The exact concept, okay? So the downfall of that is there's a lot of lymphatic tissue here, okay? Now, if one of these cells becomes cancerous, where's it going to go? There's a lot of crap in the highway right here, right, in the capillaries. So if this cell wants to jump, it's not going to go here. It's going to go here where there's nothing. And it's just going to fall into circulation, right? And then from there, it's got a straight shot to the heart, right? Yeah, so it spreads really easily. So pros and cons of mammillary tissue is share your antibodies with the newborn and protect it, or um, proliferate cancer throughout your body. So pros and cons. All right. Lymph nodes. This is what a lymph node looks like. Eerily like a radio transmitter. Okay, they are masses of lymphatic tissues along the larger lymph vessels. So you can see if this is the lymph vessel, so they're afferent, so they're going away, right? Or they're efferent coming into and then afferent going away, right? So they have what's called germinal centers. We'll talk about all these things like really more in depth in lab, but they are like a meeting place for lymphoid tissue. Okay, so rapidly dividing B cells surrounded by a layer of T cells and other accessory cells. So that's what's going on in these germinal centers. And then as lymphatic fluid is like kind of circulating through here and leaving, it's passing by these massive amounts of antibiotic tissue, right? Like immune response tissue. Okay, so if you have a disease that comes in here, it gets picked up by your antibodies and then attacked by your T cells and your other white blood cells, right? What's going to happen if you generate an immune response like right here? All the other immune cells are going to shoot over here and be like, hey, let me get a piece of it, all right? And then that space has to expand, right? And then what does that cause? What is the symptom you'll see or feel? Inflammation, right? So you have inflammation of the lymph node, right? So swollen lymph nodes. Yeah. So you feel those and you're like, ow, there's something going on here. I might be sick. Okay. So spleen. The spleen is attached to the stomach. It's right here. Anybody seen the news story? Has anybody seen? Wow, that was not correct English. I'm not an English person. Has anybody seen the news story about the doctor that removed the spleen instead of the liver from, or removed the liver instead of the spleen from a patient? It was this week. This is the spleen. Oh wow, no. Okay, you guys need to open up your eyes to the truth and what's happening in the world. So there was a doctor down in, fun fact, Destin, Florida, which is about 30 minutes from where I came from about a year ago. I used to live there. I did not know this doctor, but I've been in that hospital before many times. And so there's a spleen right here, right? It's right next to the stomach. It's pretty much attached to it, but it's right there, okay? It's fed by the splenic artery, okay? So there's one artery and one vein going into the spleen. So that artery goes up into here, up into here, up into here, and it goes up into here. And then you have red pulp and trabecula and white pulp with it, okay? So there's a germinal center, right? So if this is the artery or arterial, this is the germinal center around it, and that germinal center is the area with the is it B cells? Yeah, B cells, and then the margin zone around that, right, is the T cells, and then you've got trabecula around that. Trabecula is like a surrounding thing, okay? And then you have venous sinuses right here. So arterioles, so the blood comes through here, it seeps out into the splenic tissue and then back into the venous sinus, okay? So the marginal zone is the region between the red and white pulp. So if this is red pulp and this is white pulp, the marginal zone is this middle section. And it sequesters antigens from the circulation and presents these antigens to lymphocytes in the white pulp. Okay, so it's grabbing antigens that are floating around the bloodstream, and it's going, "Hey, build your dictionary. Here you go." So this is where those cells mature. Okay, so there's not really like an immune response going on right here. It's more of like a maturation of the immune cells. Okay, and then and sometimes you might have an immune response within the spleen. The bad thing about that is the spleen is not built to inflame. Okay, it is really not good if your spleen gets big. The spleen, just for funsies, if you feel like a liver, okay, really hard, like definitely there's some form to it, go to the butcher shop, ask for a liver, go feel that. It's like hard, like you can feel that. The spleen, you can push your finger through a human spleen, no problem. Like it gives. So it is not built for like rapid expansion. It will explode if that happens. Okay. So spleen, liver, two different things. Not even really the same color, but really hard to mix up. Oh, great, there's pizza. All right, so also the spleen sits here. It's here. Can you see that? It's here, okay? The liver is here. It's right over here, and it's underneath your rib cage, right over there. Completely different size of the body. Go Google that on your own time. It's a wild story. Lymph nodes. So there's lymph nodes in the tonsils, the malt, which we'll get to, Peyer's patches, which are aggregated lymphoid nodules in the intestines. Your appendix has lymph nodules. You didn't think it was worth anything, huh? All right, and then ball, which we'll get to too. Okay. All right, let's start with tonsils. So tonsils. So you have tonsils, probably. They're back here. Palatine tonsils. So your palatine tonsils. Tonsils. Swollen due to infection. Another thing about the lymph nodes, the lymphatic system, you can remove like all of it. What's that about? Okay, if it's so important, why can't you just take it out? I don't know. So anyway, tonsils are located in the roof of the posterior superior wall of the nasopharynx. Nasopharynx and oropharynx. All right, so you start with your oropharynx right here, and then your nasopharynx in the back. So they're all the way in the back, okay? All right. There's also lingual tonsils. This is under your tongue. So if this is your tongue, you have tonsils actually here and here, okay? This is what they look like in histology, and we will look at this more in depth in the lab, okay? But just know, lymphatic tissue. So these are barrier tissues, right? They're right there. If you try to swallow something crazy, your tonsils are going to react first, okay? First line of defense. MALT, mucosa-associated lymphoid tissue nodule, okay? These are Peyer's patches, is what these are. So there's areas in your mucosa, and you can actually, a fun dissection to do is you can actually strip your mucosa off of your intestinal lining. You can cut the mucosa and open it up. You can hold it up to light, and you can see little purple dots all over the mucosa, and those are called Peyer's patches. And it's a really, really fun dissection. But we are in anatomy online, so we won't get to do it, but I'll tell you about it. Okay, so these are Peyer's patches, and they are another barrier defense, right? So if this is food, it's not, but let's pretend this is food in the middle, right? You're absorbing stuff in through your colon, and then the Peyer's patches are catching all the bad stuff that didn't get caught by the tonsils, okay? So a couple barrier defenses. So you have tonsils, you have skin, right? Your skin keeps stuff out from entering your body. There's little lines of defenses all the way down. Your stomach actually is a barrier defense, right? Because it's acidic. So it's going to kill a lot of stuff. and a lot of stuff's not going to make it through, and it's going to break down certain things, but some things will make it through, right? All right, and then you have Peyer's patches, which are within your intestine, and those are okay. So these are, when we say barrier defenses, we're talking like actual structural defense. Okay. Appendix. Your appendix is right here. It's your vermiform appendix. Another word for it. Let me show you something cool. I have a new picture. Here's a picture. Okay. Your appendix doesn't always look like this. That's not always the spot that it's at. Right there, the little hanging down thing right there. There is, and it's one of my books. I have a thing that tells you how often that happens. But anyway, so there's like different ways your appendix can sit. And let's see if I can pull this real quick. Here we go. So in 64% of people, the appendix is retrocecal. So it's not even visible, right? Which means when they take a CT of your appendix because they think you have appendicitis, 64% of people, they can't even see that, right? In 0.5% of people, it's behind the ileum, so post-ileal. If this is the ileum going to the cecum, right? It's looped around behind the ileum. And 1% of people, it's pre-ileal, right? And then 32% of people, it's pelvic. So it's where it's supposed to be. Only in 32% of people. That's it. And then, oh crap, what did I do? And then 2% of people, it's subcecal. So it's hanging off, it's hanging to the right a little bit. So it's either hanging to the left or hanging to the right. And in 32% of people, it's hanging to the left, right? But 64% of people, not even visible. All right. Isn't that crazy? Anatomy is cool. Don't you love it? All right. So this is the appendix. It's got some inflammatory response stuff in there, some lymphoid tissue in there. Okay. So all right, we're gonna go through, what time is it? 6:45. We might make it through. We'll see. Let's see where we're at. All right, so immunity. So there are two different kinds of immunities, okay? So there's barrier defenses. So there's innate immune system and adaptive immune system. Innate immune system, what you're born with. Like, I was born this way, baby. Innate immune system. Adaptive immune system is how your body has adapted throughout its entire life. So you're building up the adaptive immune system, okay? Things that you're born with: skin, hair, cilia, right? Mucous membranes, mucus and chemical secretions, digestive enzymes, stomach acid, barriers, physical, actual barriers, all right? Peyer's patches, tonsils, stuff like that, okay? Then there's internal defenses, so there's inflammatory responses, right? There are complement proteins, and I'm gonna warn you right now, we're gonna go over complements. You have to know them. They're confusing. You have to know them. You have to know the cascade, okay? There's phagocytic cells. There's cells that eat other stuff. And then there's natural killer cells, okay? So the difference between innate and adaptive is this is present and functioning at birth. It's non-specific. It's just killing stuff. Or like blocking stuff from coming in, right? Like your skin doesn't at any point go, oh, that's a virus from Africa. Don't let it in. Like, kick it out. It doesn't do that. It's just like, virus, you can't fit. Suck it up. Get out of here. All right. Or somebody sneezes on you, it just bounces off, right? So they're non-specific, they're localized. Obviously skin's generalized, but like your hair and their cilia within like your lungs and stuff that create your innate immune system. And there is no memory, okay? Your skin has no idea what happened 2 seconds ago. It's stupid, all right? So there's no retained knowledge of what just tried to get in there well, right? So, oh, I forgot to do my favorite part of the lesson. Hold, please. Hold, please. Hold, please. Look at this guy. Look at that. Ben Franklin over here. This is Dr. Pyre. He found Pyre's patches. Okay, moving on. All right, so immunity. All right, so phagocytic cells, another one. Call me DJ Khaled. Okay, so these are non-specific. This is your adaptive immune system. Okay, and it is building up over time. Okay, it takes years to have a full immunity. Okay, and some people don't even get all that. Right? We have people who have autoimmune diseases who don't build an immune system correctly, and they're at risk for things. Right? So, or we give them medications to kill their immune system because we don't want them to have an immune system. Right? So that is the adaptive immune system. We don't give people medications to kill their skin and hair and celiac, right? We give it to kill their adaptive immune system. Because your adaptive immune system over time goes, that's bad, take it out. I already knew that, that's bad, okay? They're specific, they're systemic, they're all throughout your body, or they float throughout your body. They have a memory, right? There's antigens, and there's little tags on each little one that run into stuff and go, hey, I know you, come here, all right? They're versatile. They can do all kinds of crazy stuff. And there's a tolerance system built into it. So they might not respond to like a small little amount, but then once you hit a threshold, boom, it creates a response. Okay. So this is vertebrate immunity. I don't know why we're specifying vertebrate. It's human anatomy, right? Are we in other anatomy and physiology? Ooh, fun. We can go outside of human anatomy. All right. So innate and adaptive immune responses. So your surface barriers, your skin. So pathogens try to get up in your nose, right? And you've got internal defenses within your nose. So you have mast cells and basophils, and those are these, right? And they're running into the pathogens, and then they're killing them, and they're secreting histamines, and histamines are like tagging them, and then the killer cells, the monocytes, and the phagocytes kill them, right? Murder. Okay, so that's all going on. Other things, skin like is a blocking, so the pathogens can't enter this way. They gotta go up this way, right? So if somebody sneezes at you in your face, it's not gonna go straight through your nose, right? They're gonna hit you at the right angle and go up your nose. They can also go in your eyes and mouth, but that's beside the point. So it goes up this way, right? And then into your nasal cavity, okay? So what's going to happen there is you'll have internal defenses that kind of set off your mucous membranes. So mucous is quicksand of the body, right? So the pathogens jump into the mucus and it slows them down, and then your body goes, hey, I hate you, and then it kills them, right? All right, and then you have internal defenses, so phagocytes, natural killer cells, antimicrobial proteins. So your body will secrete things that will kill microbes, right? So histamines, inflammation, fever. Fever is a normal immune response. It is not a virus blasting up the heat, right? Fever is your body cranking up the heat going, you won't be able to survive this. And then the virus builds up, and then it goes, crap, you're surviving this. And then you have to take Tylenol, okay? So fever, not a great one, but it works. And then, let's see, immune system, so that can be more effective, right? So the innate immune system enhances the adaptive immune responses. So there's certain things within your innate immune system that are just pushing the adaptive immune system along, right? They're helping out. Okay. So another thing that's going on in here is you have adaptive immunity. So you have all that going on here in your innate immunity, and then in your adaptive immunity, you've got T lymphocytes, which are responding. They're triggering memory cells, which trigger effector cells, and then you also have B cells that have memory cells and effector cells. The B cells will tag them with the antibodies, the effector cells will come back around and push the immunity along, okay? Phagocytic cells, eosinophils, neutrophils, monocytes. They eat stuff, okay? That's all I gotta say. Natural killer cells. So those are these. They're large granular lymphocytes. They are immunological surveillance. I didn't put that word there. I'm just saying the Georgia government did. Okay. They stimulate leukopoiesis by a variety of cytokines. So IL, interleukin, and CSF are released when the infection is in the body. So they are picking up on an infection and going, hey, I'm going to secrete some stuff, right? They're pushing things out. There's interferons, which are a type of cytokine. Those are secreted by lymphocytes and tissues infected with viruses. So there's alpha, beta, and gamma interferons. Don't worry about that. Just know that there's a whole bunch of crazy stuff that's going on, okay? All right. So complement cascade. This is important. Learn this whole slide, okay? Memorize it, commit it to memory, answer the 2 questions on the test about it, and then move on with your life. All right, so let's say this is an invading pathogen. This is a circle, right? Maybe a coronavirus. Okay, so it's going to get tagged with an antigen, right? And where does that come from? That comes from here. So it's got an antigen on it, and it's going to get tagged with an antibody because the antigen will pick up on it, right? So the antibody will tag to the antigen, right? And your body, so this is happening automatically. There's no like response to it. Like there's antibodies floating around that link up with this. They pass by and they go, oh, red flag, and then they grab on, okay? Like a boyfriend that will leave your house. All right, so antibody flags the antigen, okay? And then you have complement proteins that start linking onto that, okay? So C1 binds to an antibody complex. So you've got 2 antibodies that link up, 2 big red flags, all right? So 2 best friends go and, hey, that guy's a loser. And then you have a protein that's linking to both of those because remember, it's scalable. So if it's not enough buildup that the antibodies are catching it, your body doesn't think it's a problem, okay? So you'll start linking that. You'll create this protein complex. So C1 will bind to an antigen antibody complex. So you have antigen, and then an antibody flags it, and then a complex binds to it, which attracts a C1, okay? That will cause a complement component C2 and C4 to split in 2. So C2 and C4 will see this, right? They'll recognize that chemically, and they'll start breaking up, okay? And then you have fragments from C2 and C4 combined to form an enzyme called C3 convertase. So you're taking half of this, putting them together and creating C3 convertase. C3 converts ACE. Convert, change, ACE, protein. A protein of change. Cool. So C3 convertase splits into 2. That'll create 2 even C3s, right? And you have C3A and C3B. Sorry, C3A and C3B. C3A will attract the phagocytes to the infection site. So the phagocytes are just floating around in the blood, and they're not noticing the antigens, right? Not yet. So they pick up on the C3As and they go, oh, there's something going on here. I want to hang out. Are we going to beat up this guy? So these are your friends' boyfriends who are good guys, and they come over and they go, oh, we don't like this guy. We don't like this boyfriend, okay? C3B links to the surface of the pathogen, or it links to C5 convertase, right? And then it links to the surface of the pathogen, right? So it breaks up and then it links up, right, onto the pathogen. So this is a whole bunch of C5A right there, okay? So a fragment of C5 joins C6, C7, C8, C9 to form the membranes of the tag complex. So this C6, 7, 8, and 9 are just floating out in space, right? And then they go, oh, there's a C5A over there. Let's all join together. And then all of those proteins create an attack complex, and then they jump the deadbeat boyfriend in the middle of the night, and they make a hole in the plasma membrane, right? So water, when there's a hole in the plasma membrane, will rush into the hyperosmotic cytoplasm. So water in the interstitial fluid or the blood or whatever, right, will rush into that, and it will cause it to lyse. So you're blowing up the balloon too much and it's popping, okay? So the other thing that's happening is these phagocytes are coming to the fight a little bit late, and they're just starting to eat stuff around here, okay? So they're just cleaning up the mess, right? So this whole thing is the girlfriend, your friends going, hey, boyfriend, you're a loser. And then that inflates his ego too much, and then he pops, and then friends' boyfriends come in, and they beat the crap out of him, right? I don't know if I can promote violence. We're going to move on. Emigration and diabetes during inflammation. This is a big word. Okay, so what's going on here is let's see if I can make this like way simpler. Hang on. Okay, so these white blood cells, right? They respond to the chemicals that are released by pathogen and chemical signals from nearby injured cells. Okay, so when this is released, it's going, help me, help me. And then somebody is hearing that, but it's not a bad guy, it's a good guy, is going, hey, what's going on over here, right? And so they start moving through these capillary walls, and they come out and they go, hey, we want to beat this guy up too, right? So they're responding to the response, okay? So this injured area and all of these pathogens that are injured, they're also creating the same like signal, right? And then these come up and they pick up the signal and they go, hey, what's up, guys? They squeeze through like flubber, and I do. Look, this is what it looks like. They're squeezing through it. Like if these are red blood cells, they're like pushing their way through. You can see them kind of like squeezing through. Yeah, and then they fight each other. Go Google immune response fight pit on YouTube. There's a lot of cool stuff on there. Not fight pit, but you can see them like battling it out on there. It's really cool. There's a lot of fun videos if you're a dork. So they release, so they squeeze through those capillaries and get into the connective tissue and the other tissues, right? So they're out here, not in the blood vessels, and they're concentrating on the area where the chemical is most concentrated. So this is called positive chemotaxis, right? Like fixation on a positive upregulation, right? And then monocytes will differentiate into macrophages that phagocytize the pathogen. So they're eating up all the little pieces, right? And these are the boyfriends coming to the rescue and picking up the pieces. All right. And then the eosinophils and the neutrophils release chemicals that break apart the pathogens. So they're breaking up, they're getting popped because their ego's too big. And then the eosinophils and neutrophils are popping them even more, and like breaking it down. And then you've got macrophages that are eating all of the leftovers, right? Okay. Adaptive immunity. I want to look at this and I want to decide whether or not we're going to continue because I think this is too much and I want to talk about it later. I want to talk about this on Thursday. Okay, so we're going to cut this 15 minutes short. You're welcome. My gift to you for testing you this week. And then we're going to go over immunity, adaptive immunity, and immune response, as well as system disorders on Thursday. Okay. So all of these things are going to happen later. Okay. Because I don't want to get into this and then run out of time. So we're done. Any questions? Does anybody have? I'll leave this up. And then if you guys have questions, I'll click to a slide. No questions? All right, well, I'll hang out for like 5 minutes, and then you guys can have a little bit of a longer break, and then we'll meet back at the lab. No questions. Am I really that good at explaining immunity? I didn't think I was, but I'm glad.